Are recording now.
Hey, hey guys, welcome to the Pandas and NumPy workshop. It's gonna be a really short, small, sweet workshop that we're conducting. So let's get right to the chase. So first off, I just opened a new Jupyter notebook. It's an empty one. So yeah, let's just get started. So Pandas and NumPy are basically like some libraries that you can use for playing around with your data in your data frame. So yeah, to import them, you just okay. So let's just write import. So basically, there are some shortcuts that I want to like show you guys before we get started. So in Jupyter Notebooks, if you didn't know, you could press you can hold the escape, and then when you hold your escape, you're in a particular host mode, I think, and then you can press B to get a cell below, or A to put a cell above that, or you can when you press escape and you press M, it becomes a markdown, so you can just write notes. So it's basically not code. So yeah, I'll be using this a lot. And if you want to run the cell, you do Shift Enter. Yep. Okay. So that's about it. Let me now change this back to code. So I can delete this by holding escape and pressing D. There we go. Okay. So let's get started. I'm going to create a markdown. I'm going to write Pandas and NumPy. Okay. Cool. So now let's run all the import statements. So import statements, right? Okay. So we have we're first going to import Pandas as PD. Import NumPy as NP, right? And then let's also import matplotlib. Matplotlib is basically like a plotting library that usually people use. So import matplotlib.pyplot. We're using pyplot and as POT. Okay, and then we're also going to include this thing called matplotlib inline. Yeah, this just helps us with graphics. So yeah, let's now move on to the NumPy array 6, right? Okay, cool. So basically, in NumPy, to make an array, you just let's just name it array 1D, right? And then you can just simply just write the numbers, and that's basically a sample 1D array. And a multi-dimensional array would be you putting multiple arrays in it, so you can do it like this, and then you can like assign. Yep. Okay. And then now to make a NumPy array, this is just basically kind of like a list in Python. So to make it a NumPy array, you do np dot array, and then you put in the name. And then similarly for this one. So yeah, you can name it the same thing. So it's just gonna output that. So yeah, now you can see how it looks. So this is basically how it looks. I'm running Shift Enter, and yeah, let's also run the multi-dimensional array to see how it looks. Yep. So there we go. Next, So you may be asking, like, why do we need NumPy arrays when we can just use lists, right? So the answer is, let's say, okay, let's just name this list A and 1D array A and MD, right? A, okay. So let's print this out, right? So these are lists, right? And the A's are NumPy arrays. So let's do this. Let's call this, and then let's do times 2, right? And then before we run that, let's do A times 2. So this basically outputs we have that in. Now let's just run 1D.
You want to change to array 1DA for the second one.
Thank you. Array 1DA. So if you see the difference, did I write it correctly?
You need to rerun the line 37, when you instantiated, because you overwrote it.
Yeah, you're right. Yeah, this is the point that I was trying to make. So for lists in Python, when you do times 2, it repeats the list twice. But array, it's more mathematical. That's why we use NumPy arrays here. So yeah, I think I should do a better job naming my arrays, and I'll do that next time. So yeah, so that's basically the difference between Python lists and NumPy arrays. So that's why we use NumPy arrays a lot. So now let me just show you some useful examples for NumPy arrays. So some useful functions, right? Okay, so first let's do, so if we want to find the max of the whole NumPy array, we just do run max. If we want to do min, it's the same thing. Min is 2. We can also find the mean. So dot mean, right? And the mean is 6. We can also return the standard deviation, which is STD, standard. And then we can also sort. So we can do sort. And then it's sorted. So now we can again output it, and then it comes in a sorted order. Yeah. What else? We can also, okay, so we can find the mean through different axes. So we can use this for the multi-dimensional array. So let's try using this, right? If we do this dot mean, and then we do axis equals 1, right? This outputs the mean for the rows. Yeah, and output that, and then see, this is the mean for the rows. Yeah, and let's just change the axis. Returns the mean for each of the rows. So because it was I think it was 3 by 3 matrix, that's why you have 3 means for each row. And similarly, if we do it for 0, then it does it for the columns, each column, right? And then that's the mean for each of the columns. We're using this one here. Okay, so that was basically this. So let me now show you how to, should have shown you this before, but let me now show you how to generate random arrays. So you can do, okay, let's just call it rand and array rand, right? And then we'll call it np.random.rand. And then let's have 3 rows and 3 columns. And once we do that, that's what we get. We get we get an array of 3 rows and 3 columns. All of their numbers are given random from 1 to 0. That's 0 to 1. That's the default for everyone. And then we can also do like a normal distribution, and to do that we just add an n here. So to the normal distribution, and this will give it from -1 to 1. So this is -1 to 1. And let's say we want to do some we want to give a range for it, right? So we do rand int, and then we can do 0 and 10, and then we'll get 0 and 10, and then we can decide the shape of the array that we want. So let's say we do a multi-dimensional array, like 5 rows, 3 columns. So we'll get this. So we'll get 5 rows and 3 columns of random numbers between 0 and 10. Yep. And we named it int. That's we gave ints. That's why it's giving an integer values. Okay. So now let's go to the array basics. We already went through array basics, so let's go through some other universal functions. Let's go back to let's just use this one. Let's use array rand. Okay, so in array rand, let's see, what else can we do? Oh yeah, argmin and argmax. So argmin of just right, and then we'll just output it. Yeah, argmin. Argmin basically returns the index of the minimum. So and then argmax, this returns the index of the max, and that kind of I think it's because this was a multi-dimensional array. That's why it's doing this. Okay, let's just use this one. NP arrays. I don't think I copied that. Okay, yeah. So the maximum number is in the 4th index here, and the min is here in the 0th index, because it was only 1 to 5. And I think you can also do you can also do argsort. Argsort basically returns the array of index positions from min to max. Yeah, so that's basically some of the universal functions. And now let's go to appending arrays. So for example, let's do a equals np dot a range. Let's do a range first. So dot reshape, right? And then we'll do 3, 3. Okay, this creates a sample array. So we can again output a, and then yeah, there you go. Now let's do another one called b. Similar one, but we'll do it in a different way. So np dot random. This is in random dot randint, the one that we used before. And let's do 9, 8, right? And let's do 3. This is the shape of the array that we want. And that is an error. I do not know why. Random dot randint 9, 18. Okay. And let's just output this to see how it looks. Okay. Nice. The reason it was an error before was because it gave we gave a range from, it should be a min to max. We gave a min as 9 and max as 8, which was not possible. So yeah, yep. So we have these two arrays. Now we can do something called stacking. So we can make another column called, we can make another array called C. Then we can do np.vstack. This is a vertical stack, so stack. And then we can do a comma b. What this does is it stacks a on b. So if you let's output a, b, and c. A, b, and c. You see it stacks a on top of b. Now let's do it vertical stack. We can also do a horizontal stack, which is np.hstack. Pretty intuitive. A comma b. Right, and then we can run all this again, and then we'll just run p again. Yeah, so it just puts it to the side. We can also do it the other way around, just to show this, and then we can run this again, which you see b comes here and a comes here. Yep. Yeah, and one last thing, we can also in NumPy we can use conditional selection. So let's create an array called np dot a range. Let's just give it a range of 1, 11, right? Just some sample array. Let's now say if array is greater than 5, we do array. Okay, let's just output out. So all the numbers that are greater than array.I, it outputs that array. So we can put this into answer, right? Answer is an array name. So all it does is all the as we said before, whatever logic you apply to the NumPy array applies to each and every element in the NumPy array that we saw over here, right? So it applies that logic to each and every one, and it outputs if it's true or false for each one, right? Okay, so next we can also do something cool with this. So we can do array of array. It returns array of values that are 5. So we'll just print an answer. Yep. So these are all the values. So these only output the index, and these output the values. Okay. So yeah, this is basically all the details for NumPy. Now let's go to Pandas. Right. Yeah. In Pandas, so we use something called objects. These are like hyper arrays, basically. But yeah, we use it here. So we'll just create objects pd dot series, right? And then we'll just put 10, 20, 30, 40, 50, yeah, okay. And then create the series. I don't know what I wrote there, but it's fine. I'll just, so, and if we want to get like the second element, then we just do 2, and then it outputs 30. Third element, then we output 2, yeah. Okay, and then we can also do element-wise operations. So we can do a series, okay, let's do another one. So it's the series age, right? Let's do pd dot series, and then let's do the same thing, but instead let's give some ages 31, 22, let's see, 43, 44, 55, 60, right? Okay. Yeah. So now let's do an element-wise operation for this. So let's do series age plus series age. And then if you output that, there you go. see it outputs the double of each and every element that you find over here. So it doubles this, So it's again element wise. We can also do this for times 2. So it's going to multiply each one by 2. Here, same thing. Or we can do it 3. So it multiplies each one by 3. Yeah, we can also add. We can also like add any value, like any mathematical operation, right? Yep. Just print normal. Yep. And we can also do the same thing that we did last time for NumPy arrays. We can add boolean logic. So we can do series age greater than 40, and then it's going to output all of them that are greater than 40, and it also tells you the type. And these are this outputs another array which has all the values, but if you want which values they are, then you can just do that. And yeah, these are all the values that are greater than 40. Yeah, this is basically it's similar. NumPy is really similar to Pandas, but we use Pandas mostly for data frame basics. So let's go. Let's try to use Pandas in data frames and let's see how it goes. So. Okay, so I actually have a good data frame here. I'm just gonna make one here. Let's see. I will try to copy it from somewhere. Just 1 second. Let me stop share, and I will get some. To save time, we'll just get some data from here. Okay. So let me start sharing again. Okay. So here we have we're creating a small data frame. We have name, gender, and age. We have 3 columns, and in each column we have like the data. It's like, so Tim Miller is a male and he's 32 years, and Ann Carter is a female and she's 44 years old. So this is basically some data that we have. So now what we can do is, this is how you create a data frame basically. If you want to create your own small data frame, you can just do that. So okay, once you have, so this is still a list, this is not a data frame. If you want to create a data frame, then you do df. Usually we write df for data frame, and then pd called pandas, and data frame, okay, and then data, right? And then this creates a data frame. So now you can print out df, and then look at that. Isn't that cool? Yep. So now what we can do is we can print out the head. df.head. df.head prints out the first 5 entries in the column, and df.tail prints out the last 5 of the data frame that you have. So, and if you want, let's say, one particular column, then you can say, let's say we want all the names, right? So name, and then it's going to print out each and every name that it has in the data frame. And let's say we want to make it into a list, right? We want to make, let's say, we want to make a list of all the columns. So list, and we want to like see what all columns are there in our data frame, because this helps a lot when you're trying to look for data and when you want to like test out what's there in the data. So this is the list of all the column names. So like name, gender, and age, right? Okay. And then lastly, we can also do, well, we can also add like something to the data. So we can also say birth year, right? And then let's say 2000. And then now if we do df, it's gonna give 2000 for each and every one. Yeah, that's basically how you can do that. And you can either do this, or you can also give values for each and every one. You can say like 2000, 1900, I'm sorry, 1999, 2001, and then yeah, you can give that. And oh, yeah, you have to keep giving or I don't know. So 1, 2, 3, 4, 5, 6, 7, right? Okay, so 7. So we give for 2016, right? 1984, 6, 5 done. 2011, 2009. Right? Yeah. So and then yeah, we got all this here. Yeah, so that's basically some basics for data frames. So now let's so now where would you use this? So you would use this when you like find like a data frame online, like you find in the resources. You get the data. You don't have to do this step. All you do is get the data. Most will be a data frame, but you just get the data and then you make it a data frame. And then you can like do all that we did, and then just try to find out how many rows it has, what it does. And if you start the more you understand your data, the more you understand what you have to work with, the better things you can do with your data. So now this was exploring your data. So you're trying to like see what it has. Like this is more like knowing your data. Now now we're going to learn how to select and how to filter out the data, what you want and what you don't want. So yeah, let me get some more data. Just 1 second. I will get some yeah. Okay, I'm gonna get some more data here. I'm also going to show you something called Jovian. This is really cool. I'll show it to you in the end. So paid data frame PD dot data frame, and then it's the same thing. But here we can also give it like the range, the shape, and all that. So yeah, and we also gave it the columns that it has, and then let's do something called fill NANs. Okay, first let's do, okay, we have a lot of things to do. So data, right, and then let's just do this. Right, and then this gives us the number of bees. This gives us data dot and mostly location, and this is consecutive. So we're gonna do a consecutive one now. Consecutive A, and what other letter? E. Yeah, let's do E. So E. Right, and yeah, so that's where it shows everything. And yeah, we can also do it for both. So this is like from 5, and then this is like from 6 to everything. So everything until 5, from 6 to everything. So that's how we show the index. And then data dot block. We can also do comma. Let's what else did we do? So we didn't do C, we didn't do F, and we didn't do I. We didn't do I. Yeah. So we can just, and this is non-consecutive, right? So that's what we get. Okay, so let me just write this again. So this is consecutive. and this is non-consecutive. Yep. Okay. Yeah. Now we can we can also do like the same thing that we did here, but we can also do df dot as type boolean, and then we can see how many booleans it has. So let's first look at the number of we'll see the number in the number of non-zeros in each column in, let's say, rows. Yeah, let's do columns first. So axis equals 0. Yeah, see, name has 7 non-zeros, gender has 7 non-zeros, and age and birth year also has 7 non-zeros. Now we do it for the number of rows, and then it's 4, 4, 4, 4 for each. Yeah, let's say we add, let's just change this a little bit. So let's do age 0, right? And then let's do NaN. I don't know if it'll do that. Yeah. I actually don't know how to give NaNs. But yeah. It should show that there is 1 0. Yeah, you see, age has only 6 non-zeros. Yep. So now what we can do is, if your data frame has NaNs, NaNs are basically like empty positions. Oh yeah, right. So I can just give empty. Nah, I'm just not gonna do that. So let's not do that. We'll go to another example later on. So we can also do df dot fill in ends. This is just for your reference, guys. So your data set will have blank spaces, and it'll come with NaN. So they would look something like this. They would look like NaN, like that, and then that means that there is no entry over there. And especially for training machine learning models, you really don't want NaNs in your data set. So to remove them, you can either do fill in ends with 0, and then you can do as type boolean. So you can also mention the type, and you can also do the sum as x-axis. That's 2. Yeah. I don't. Yeah, that's the thing. So our data frame doesn't have any NaN, so it's not going to fill anything. So you can just use this as a reference for you guys. Okay. So now let's go to some data exploration. I already have a data set that I can pull up right now. So let's just do a markdown. Right. Okay. So now we're using Pandas here. I have a data frame called from the 2016 Olympics. So I'm just gonna bring it here. So Olympics DF. I'm gonna name it Olympics DF, and I'm gonna do PD dot read CSV. Read CSV, and then I'm gonna give the name of it, which is 2016. I don't want to get the name wrong here. Olympics, and then .csv. Right? Yeah, and what this does is CSV is nothing but a comma separated values. So it's like yeah, it's like all your data in like separated with columns. So now what it does is it takes the CSV, it reads the CSV from a function from Pandas. So we take that's why you use PD, and then it stores it in Olympics DF. So now if you want to check out Olympic DF, right? Let's do Olympic DF. So you see it shows the whole Olympic data frame. So this is the is a data frame. This is the one that I already have. So now remember, we can also do head. It shows the top 5 and tail. This shows the bottom 5, right? So we have 11,000 entries here. Yeah, so you kind of big data set. So yeah, let's do, okay, so now we have the columns as ID, name, nationality, sex, date of birth, height, weight, sport, and gold, silver, bronze, right? So now what we can do is, let's say for some reason we don't want, okay, so we don't want ID. ID is kind of useless for us, right? So what we can do is we can just do Olympic DF, right? And then we can do equals Olympic DF dot drop, right? And then we can drop any column we want. So we can drop ID, we can drop name. Let's say we don't want, because let's say we're trying to build a machine learning model to tell between the correlation between height and weight with respect to sport. Yeah, maybe the height and weight determines which sport you're playing or something like that. So maybe we don't want the ID and name to, you know, spoil the accuracy of the model. So let's say we want to delete ID and name, and then once we do that, I think we didn't specify axis, so we have to specify that we want it in the rows, right? We're dropping features, columns, sorry. So now when we print Olympic DF, we get ID and name as ID name dropped, and then yeah. Actually, you know what? I should have done this here. Let me do this again. So you guys can see both the one that's changed and the one that's not. Actually, let's do head. Yeah, this should look better. Yep. Yep. See here, first we had ID and name, and now we don't. Yeah. So now we can also do something called df.describe. This is going to be really helpful for you guys. Okay, so yeah, this is going to be really helpful, especially when you're looking through a lot of data sets. So what you can do is you can download the data set and then have it in the, you should make sure that this data set is in your folder, or you have to give the whole path of this data frame. Okay. And now what we can do is we can do describe. Describe. Sorry, I can't spell. Yeah. And then this is what it's going to say. It's going to give the count. It's going to give the mean. It's going to give the standard deviation. It's going to give the min. It's going to give, this was called something, interquartile range for each of the ones. So yeah. And yeah, so this df.describe is really helpful. And you can also do df. only, let's say we want to see only sport, right? And then .unique. Okay, so what this does is it shows what are the different types of sports that are there. So athletics, fencing, taekwondo, cycling, triathlon. You have all of this here. So you don't have to go through the whole data set seeing, oh, what kind of sports do they have. So you can use techniques like this to, like, you know, see what your data is and try to understand your data, because the more you understand your data, the better you'll know what to do with it. So now let's display correlations between features from like 1 to 0. So we can do that by doing the Olympic df.core. And this correlates from height, weight, gold, and see, it gives you the correlation for each one. And then let's plot this out, right? Let's do pair plot. SNS dot. Oh, we're not using Seaborn. We didn't import Seaborn yet. Okay. Okay, let me actually show you first how to plot using matplotlib, and then we can use Seaborn later on. Just 1 second. Let's see if we did import Seaborn here. Yeah, let's also import Seaborn. We didn't import Seaborn before. So Seaborn is another library used for plotting graphs. So Seaborn as SNS, and then we're also going to do SNSC set. Okay. Yeah. So for matplotlib, we're doing it as PLT. I'll just show you a really quick example for matplotlib. So let's say we have this multi-dimensional array that we want to plot, right? So let's just do this, and then let's add another column down here. Oh, I had it above. I wanted it below. So below, and then I can just do plt dot plot, and then I can say array empty multi-dimensional array, and then look at that. So it just plots it for you. And you can go on to Matplotlib's website, and then there's so many other functions like this. You can do like, you can do bar graphs, whatnot. So yeah, and that is really helpful. We are looking for visualizations of your data, and we want to see how it looks. So especially for like to stand out, you have to show like visualizations of your models, how they perform, and especially if you're doing data exploration or data analysis, you have to show your model performance or your data and why you're doing what you're doing, because that's really important. So now let's just do a pair plot and see how the pair plot looks like. So we're using Seaborn. So SNS, we import SNS, and then pair plot, right? Olympics. My capital, so I'm just gonna keep that in here. Okay. So it will take some time because it is, yeah, it's huge. You know, honestly, I shouldn't have done it for everything. Yeah, guys, my bad. So we might wait for a while. So, you have any questions? Oh yeah, okay. Here it is. So such a beautiful piece. So it just plots all this here. So one more thing that you have to keep in mind is that when you see a high feature correlation, like if the features are like very similar to each other, which obviously height and height are similar, weight and weight are similar, but apart from that, if you see anywhere else that it's really close to one, or it's like one for one of the features, then you use feature engineering to like separate it out. We'll talk about how to do feature engineering now. So first, before we go to feature engineering, let's go to boolean selection. So to boolean selection. Okay. So in boolean selection, we can do df. Oh yeah, we can do df.sport. Let's say we want to do sports, right? Okay, and then equals athletics, right? So if let's say we only want how many people are participating in athletics, right? And then it returns all of the numbers. You won't obviously get all of them, but you can like you can use this, and you can also make this into like a, right? And then you can do a dot head. This will work. Oh, yeah. So it returns the first 5 people, if they're athletics or not. And you can also you can also do sports is in, and then is in is a different function. So let's just try that out. And then we can move to feature engineering, which will be really important for you machine learning people over there. Yeah. Yep. Okay, let's do athletics, and let's also do volleyball. Why not? Right. And there you go. So you have, again, a true and false. So it is in values will return all the true values for when if it is in that column or not. So in the 0th column, the word athletics and volleyball is there. So that's why it would print it out. Athletics or volleyball. So it's either one. Yeah. So now let's go to some feature engineering. And let's do some basics of it. Basics of feature engineering. Okay, so now let's say, okay, let's just do this blindly. Just 1 second. So let's do BMI. Let's say we want to calculate the BMI, and we want to like do a new column, and we want to add BMI to it. So how do you calculate BMI? Right, BMI is basically all the weights. So the weight divided by the height, and you have to square it, right? And that's BMI. And you can now print out dot head, and then you're gonna see another BMI column with the BMI calculated for each of the person. Yeah. So now let's we can also use we can also find how many males and females are there. But as you see here, wait, let's go here. So it's male, female, right? Usually machine learning models don't like words. Remember we were talking about it before in our Let's Talk events. So what we can do now is we can take that column, say sex, and then we can take sex dot map, that map, and what we can do is we can do female as one. Female is interesting. Equals 0, and male equals 1. Right now, once we output, oh, invalid syntax. What did I do wrong? Doing something wrong. Olympics df dot map male male. Oh yeah, it's not equal to it. Yep. Okay. Now once we do df dot head, we're also going to get 1s and 0s for a female or male. So it's really important that you convert all that you have into integers, mostly integers. So it'll help you a lot. And now let's go into one-hot encoding. One-hot encoding is basically this technique that you use to display categorical features. So let's do this. I don't think I have this one, but yeah, we can just do it once really quickly. Yeah, let's just do olympics.df. Okay, let's see. Credits.csv. Let's do sport. Let's try this out. Sport, and then let's do. Okay, let's do another array. Let's do array. Okay. Let's do PD dot get dummies, and then let's do .df comma columns, and let's do equals. Boom. Yeah, this should work. Yep. Then array. Boom. So now you see here, what we did was in all the sports here, we have athletics, fencing. Okay, where did we have this, right? We have athletics, fencing, taekwondo, cycling, triathlon, volleyball. So these are the different sports we have, right? So now what all we're doing is what one-hot encoding does is it takes all these different features and it makes them into different. It takes all these inputs and makes them into different features. So it makes them into different columns here. So you see here, sports aquatics, sport taekwondo, sport tennis, sport triathlon. So these are different features. And what all it does is it just makes different features out of them, and then it deletes the sport column. You don't even see sports here, right? And this is how you clean the data. This is called cleaning data. So once you do this, and when you have a data frame free of string values, so you can keep BMI, you can keep the number of bronze and gold because they're all numbers, right? Oh yeah, you can also drop NaNs. Yeah, let's do that. So let's do drop NaNs. Where was that thing? Yep. So array dot fill NaNs. Oh. Just 1 second. Yeah. So all we can do is we can do array, and then we'll just do array again, and then we'll do where do we find NaNs before? Let's do config df, and then we'll see how it looks like. NaNs. Okay, we found NaNs here in weight, right? Let's do it in weight. Let's change it in weight. So right, and then dot not NA. Yep, and then let's just do array dot array, and then you see here in weight, wherever it was NaN, all the columns where NaN is there is dropped. Let's print out array here before, and let's see the difference. So let's see in weight. You see here the 12th one had an NaN in weight, right? But over here, so NaN was basically it meant that there was no weight for that person. Like there was no data for the weight and height for that person. So all we did was we just dropped that. We dropped all the columns whichever had NaNs. So you see here the 12th column is not there. See, it's 11, 13. So it got dropped. Yeah, that's basically it. Now, yeah, now all we can do is actually we can do it for each and every column for it, and then we can drop all the NaNs. but yeah, that's basically this. And wait, let me go back and show you guys. Yeah, so in the end, let's say you clean all your data, right? And you cleaned all your data, meaning you have everything in numbers and all your NaNs are dropped. Your NaNs are dropped, or you figured out how to, like, manage your NaNs, right? So what you can do to store is you can do array dot to CSV, right? And then you can store it as cleaned data, right? Clean data, and then you can store dot CSV. And then there you go. And as you see here, let's go here. So this is where it is, and you see here, clean data.csv is here, and you can again import it. So yeah, I remember we used this here, the same one. We can get it back here, and then we can use it here. So we can just do clean df, right? And then we'll bring this one in, clean data.csv. We again imported it, and then we can do that, and then it's the same one, right? So this is basically the basics for pandas and NumPy. We're like 5 minutes over time, but I think we started 5 minutes, so we ended exactly in an hour, which is good. But one last thing I want to show you guys before we end it today, end our session today, is Jovian. So Jovian is this really cool thing that you can use to like store all your code, right? So let's say I have all this code and I want to store it, right? So all I do is I do import Jovian, right? Import Jovian, and then I do Jovian dot commit, right? You should already have a Jovian account for this. But yeah, you can. I'll send you guys the link to Jovian. This is my Jovian here. You can go take a look. There's Pandas and NumPy review here, cheat sheet, and some of my other products. You can take a look at it. But yeah, I'll show you. So, and then we can do projects. I'm gonna delete this anyway, but yeah, I'm just gonna write it as session code, right? And then I'm gonna save it. It's projects. So this is one of my things. And then it tries to save notebook, uploading notebook, capturing environment. Yeah, when you're actually saving it, sometimes I've already done this before, so it doesn't ask me for my API key. But usually what it does is see, it's already saved now. But usually what it does is it asks for the API key, and I get my API key over here, so I can copy mine. And then you see notebooks, session code. See, it got uploaded. But yeah, I'm gonna delete this anyway because because I don't want it to be stored now. I don't want to be stored here. But yeah, I want to give you guys this cheat sheet over here, so you guys can take a look at it. If you have any questions, you can ask me. These are some crazy imports here, but yeah, the only things you care about is SNS. So and one thing I want to tell you guys, this, if you try to run this, it won't work. This code doesn't work. One more disclaimer. Yeah, this code doesn't work. This is just a cheat sheet for you guys to go look at each and everything. Because look, this is really absurd. It has nothing printing out here. Most of it is not printing out anything. So yeah, these are just like, it has, some descriptions for each and every one, so you can use it. So yeah, you can take a look at it from here. And yeah, I'm now open to questions. So anyone has any questions, please let me know. Now it's a good time. Yeah, thank you so much for coming. I will stop the recording here.